Hello, my students in grade 7. This is a new mathematics lecture, and the title of our lecture is Algebraic Expressions 2. What are the objectives of this lecture? Number one, how we find the numerical value of an algebraic expression. Number two, we will refresh memory of what we studied before in this lesson in part one, how we multiply, how we add, subtract two terms or monomials. Number three, expand or develop an algebraic expression. Number four, factorize an algebraic expression. Numerical value of an algebraic expression. To find the numerical value of an algebraic expression, in the algebraic expression, we have a variable. What we do is we replace the variable or the variables. We might have more than one variable in the algebraic expression by the given value of the variable or the variables. So we will be given an algebraic expression with variable or variables in it, and we will be given the value of the variable. What we do is we replace the value of the variable in the algebraic expression. Example, we have an algebraic expression which is 7 plus x. The variable is x. We are given also for x equal 3. So the given value of the variable is 3. So wherever we see x in the algebraic expression, we should replace it by 3. So we replace 7 plus, in place of x, we write 3. So now we calculate 7 plus 3 equal 10. Another algebraic expression, 10 minus y, for y equal minus 2. So the algebraic expression is 10 minus y. We should replace y by the given value minus 2. So if we are given a value which is negative, we always replace the negative between parentheses. So we write 10 minus, and we put the value of y, which is minus 2, between parentheses. Here in calculation, we should follow PEMDAS. So what we do is we multiply the two operations after each others. So we write 10, negative times negative is positive, so 10 plus 2 equals 12. Another algebraic expression, 2x plus 5. This is the algebraic expression for x equal 3. So the given value of the variable is 3. So we replace the given value x by 3. Here we have 2x. What do we mean when we say 2x? We mean 2 times x. So the value of the variable is multiplied by 2. Also, whenever the value is multiplied by a number, we replace it between parentheses. So we replace 2 into 3 plus 5. Also, we multiply first. 2 times 3 is 6 plus 5, which is 11. So in calculation, we follow PEMDAS, as you can see. Since multiplication is stronger than addition, so we multiply first. An algebraic expression x squared minus 3y minus 4. So here we have two variables. So we will be given a value for x, which is minus 1, and a value for y, which is 2. Also here x has an exponent. Also we replace x between parentheses. So negative 1, all of it square, minus 3, we replace y between parentheses, which is 2, because it's multiplied by negative 3 minus 4. Minus 1 square means minus 1 times minus 1, which is 1. Negative 3 times 2 is negative 6, and we write negative 4. Now we start calculation from left following PEMDAS. 1 minus 6 is minus 5, minus 4, so the answer is minus 9. We get it using our calculator. Now we have minus 2x cubed y squared z t squared. Here we have 4 variables. So for each variable, we will be given a value, and we replace in the given algebraic expression. After we calculate, we get the answer, which is 720. Please apply these exercises and practice them on draft well to understand how we get the numerical value of an algebraic expression. Now we will refresh our memory of things we studied before, and these are very important rules. When we talk about a monomial or a term, each monomial has a sign, a coefficient, and a variable, and the variables might have exponents. For example, 3x is a monomial, minus 2y is a monomial, 5x squared minus 3xy squared z cubed. These are all monomials. How we multiply two monomials. To multiply two monomials, the rule is we multiply sign times sign, number times number. Both the sign and the number, we call them coefficient. We multiply variable times variable. If we are multiplying same variables, so we keep the variable and we add their exponents. If we are multiplying different variables, we keep all as they are. As an example, 3x squared y multiplied by minus 2x cubed y squared. So we start positive times negative is negative. 3 times 2 is 6. X squared times x cubed, same variables. So we keep the variable x and we add 2 plus 3 is 5. Y times y squared, the same variable y, we write it y. Here the exponent is 1, so 1 plus 2 is 3. The third rule, how we add or subtract monomials. We can only add or subtract like terms or similar monomials. Like terms or similar monomials, those that have the same variables and same exponents. We add or subtract coefficients, we keep the variable and the exponent. As an example, 4x plus 2x, these are like, so we can add them. So we say 4 plus 2 is 6, and we keep the variable x as it is. 3xy squared minus 7xy squared. We have like terms, so 3 minus 7, we do it on calculator, it gives minus 4, and we keep xy squared as it is. Here, the last example, 3x squared y cubed plus xy. These are unlike terms. We cannot add them, so it's impossible to add them. So the answer is kept as it is. Now, expand or develop an algebraic expression. The following rules are very important. You understand the rule, you memorize the rule, and you can apply it directly wherever you see it. So we start. Expand or develop. Two words meaning the same thing, an algebraic expression. So we will be given an algebraic expression that has parentheses in it. To develop or expand the algebraic expression is to get rid or remove the parentheses. So in our answer, there should not be parentheses. How we remove the parentheses? To remove or get rid of the parentheses, we multiply all the factors inside the parentheses with what is before it. The parentheses might be multiplied by. You might see a parenthesis, and in front of the parenthesis, you have a sign. So everything inside is multiplied by the sign. You might have a number. So everything is multiplied by the number. You might have a coefficient, a sign with a number. You might have a variable or a complete monomial, or the parenthesis might be multiplied by another parenthesis, which we call it also a binomial multiplied by a binomial. The first rule in expanding is called a one for all rule. And the rule looks like this. We might have m into a plus b. So we have a parenthesis, and in front of the parenthesis is multiplied by m. How we multiply? We say m times a is ma. Positive times positive is positive. M times B is MB. Or if we have inside the parentheses a minus, we can apply the second rule. M times A is MA. Positive in front of the M times the negative. So positive times negative is negative, and M times B is MB. So please memorize these two rules to apply them in our exercises. And now we'll see many examples. As examples, We have minus parenthesis 2x plus 5. So everything inside the parenthesis is multiplied by a minus. Negative times positive is negative, and we write 2x. So we multiply negative by 2x, so it's negative 2x. Negative times positive 5, negative times positive is negative, and we keep it 5. So our answer is negative 2x minus 5. The second example, also the parenthesis is multiplied by a minus. 2 has a positive, so negative times positive is negative, so negative 2. Negative times positive is negative, so y squared. Other examples, the parenthesis here now is multiplied by 3. So positive times positive is positive, 3 times 4 is 12, and we keep it x. Now 3 is multiplied by positive 5. Positive times positive is positive. 3 times 5 is 15. So the answer is 12x plus 15. Now the parenthesis is multiplied by a coefficient, a sign with a number. So the parenthesis is multiplied by negative 5. So negative times positive is negative. 5 times 2 is 10, and we keep the variable a. So our answer is negative 10a. Now negative 5 is multiplied by positive 7. Negative times positive is negative. 5 times 7 is 35. So this is our answer. Now what we have inside the parentheses is multiplied by negative 3. Negative 3 times 5. Negative times positive is negative. 3 times 5 is 15. So the answer is negative 15. Now we multiply negative 3 by positive 2a squared. Negative times positive is negative. 3 times 2 is 6. And we keep the variable a squared as it is. Now negative 3 is multiplied by negative 4a. Negative times negative is positive. 3 times 4 is 12. And we keep the variable a. So this is our answer. Now x squared is multiplied by everything inside. So positive times positive is positive. Here the coefficient is 1. 1 times 2 is 2. X squared times x cubed. So we keep the variable x and we add exponents. 2 times 2 plus 3 is 5. So the answer is 2x5. Now positive times negative is negative. 1 times 3 is 3. X squared times y, because we are multiplying different variables, so we keep them x squared y. Now, negative 3x cubed y squared is multiplied by 4x. So negative times positive is negative. 3 times 4 is 12. X cubed times x, here x power 1. So we keep it x, and 3 plus 1 is 4. So we get x4. Y squared, we keep it as it is. Now, negative 3x cubed y squared is multiplied by positive x squared y. Negative times positive is negative. 3 times 1 is 3. X cubed times x squared is x5. Y squared times y is y cubed. Also, we have another example down. As I said, please practice these exercises on a draft to understand the rule. Now, rule number 2, we call it all for all. What we mean by this is m plus or minus n. So inside the parentheses, we might have a plus or a minus. This parenthesis, we call it a binomial because inside we have two things, which are m and n. Also multiplied by another binomial, which is a plus or minus b. So here we have a binomial multiplied by another binomial. When we see two parentheses multiplied together, we apply all for all. Everything inside the first parenthesis is multiplied by all, or everything inside the second parenthesis. That's why we say all for all. Now we say m times a is ma. Now we multiply the sign here by the sign here. So we should multiply m times b. M times b is mb. Also, we multiply the sign by the sign. Now we multiply n times a is na. Also, we multiply the sign by the sign, whatever the signs are, and we write the answer. Then we multiply n by b, which is nb. So everything in the first parenthesis is multiplied by all inside the second parenthesis. As a note, after multiplying all the terms using this rule, which is all for all, we check our answer. If there are any like terms or similar monomials, we should reduce them into one monomial. Now we will see an example. We have x minus 2, this is the first binomial, and x plus 3 is the second binomial. So a parenthesis times a parenthesis. We start, x times x is x squared. Now we multiply x by positive 3. Positive times positive is positive. X times 3 is a 3x. Now we multiply minus 2 by x. Negative times positive is negative, and 2 times x is 2x. Now we multiply negative 2 by positive 3. Negative times positive is negative. 2 times 3 is 6. Now, after we get this answer, we look for like terms. We can see that positive 3x and negative 2x are like or similar. So we make them one monomial. We write x squared. Positive 3 minus 2 is plus x, and we write minus 6. So this is our reduced answer. If you look at the answer, we do not see parentheses anymore. Our answer has no parentheses anymore. The second example, this is the first binomial, 2a squared minus 1 multiplied by the second binomial, a minus 5. So whenever we see two binomials multiplied together, we apply the rule all for all. So we multiply 2a squared by a, we get positive times positive is positive. 2 times 1 is 2. A squared times a is a cube. Then we multiply 2a squared by negative 5. Positive times negative is negative. 2 times 5 is 10, and we keep it a squared. Negative 1 by a. Negative by positive is negative. 1 times a is a. Negative 1 by negative 5. Negative by negative is positive, and 1 times 5 is 5. So this is our answer. Now, do we have like terms? No. All the terms are unlike, so we keep the answer as it is. Now the last example, 3y minus 4 into 3y plus 4. Also, we apply the rule all for all. 3y times the 3y, positive times positive is positive. 3 times the 3 is 9. Y times y is y squared. So the answer is 9y squared. 3y times positive 4, positive times positive is positive. 3 times 4 is 12, and we keep it y. Negative 4 times 3y, negative times positive is negative. 4 times 3 is 12, and we keep it y. Negative 4 times positive 4, negative times positive is negative. 4 times 4 is 16, so this is our answer. Now we reduce the like terms. Plus 12y and minus 12y are like terms, and they are opposite terms, so their answer is 0, so we cancel both terms. So my answer is 9y squared minus 16. This is the expanded form. It has no parentheses in it. Let's expand the following. I will give you these examples. Please apply them on draft. As the examples I discussed before, apply all these examples alone on draft to practice more. You have many exercises to practice. I've given you a lot of exercises to practice. Now we move to the last part of our lesson, which is factorize an algebraic expression. To expand an algebraic expression and to factorize an algebraic expression are two opposite things. Factorize an algebraic expression. How do we factorize an algebraic expression? We will have an algebraic expression without parentheses. In our answer, we should have an algebraic expression with parentheses. So how we do this? We will be given an algebraic expression with terms or monomials. What we do is we look at all the terms and we try to find a common factor between the terms, a factor which is found in all the terms, and all the terms are divisible by this factor. For example, we have ax plus ay minus az. We can see that in the first monomial we have a, in the second monomial we have a, in the third monomial we have a. So the common factor is a, so we write a. After we find the common factor, we open parentheses. Now each term we divided by the common factor. So ax divided by a cancels a and we are kept with x, plus ay divided by a cancels a, so we write y, minus az divided by a cancels a, so we write the answer minus z and we close parentheses. As you can see in our answer, we have parentheses. So this is called a factorized form. Now, for example, we have 2x cubed minus 5x squared. What's common? Do we have a common sign? No, because here the sign is positive and here the sign is negative. No common sign. Between 2 and 5, do we have any common that 2 and 5 are divisible by? No. So we do not have common number. Now we go to the variable x cubed and x squared. We take the variable with the least exponent as common. So we take x squared and we open parentheses. Now 2x cubed divided by x squared. We write 2 and x cubed divided by x squared. We keep it x and we subtract the coefficients. So 3 minus 2 is 1, so we write 2x. Minus 5x squared divided by x squared is minus 5 because the x squared cancels the x squared. When we have same variable, same exponent, they cancel each other's. And you can continue the other examples. The common factor in the algebraic expression, it might be a sign, it might be a coefficient or a number, it might be a variable, it might be a monomial or a binomial. Also, you can apply the other examples. Here, for example, in this one, if we look here, we have a binomial x plus 2, all of it squared. This is the first term, plus x plus 2 into x plus 1 is the second term. Now, between the first term and the second term, what do you see common? What do you see in the first term? The same thing you see it in the second term is the binomial x plus 2. So we take as a common factor the binomial x plus 2, and we divide each term now by the binomial x plus 2. So x plus 2 squared divided by x plus 2 is x plus 2, plus the second term divided by x plus 2 is x plus 1. Now we reduce the like terms and we get our answer. Also here you have many solved exercises. You can apply them by yourselves. This was our lesson. I hope you watch this video and you understand everything inside. So please, after you watch this video, if you have any answer, please contact me. Thank you.